Hello there. In this video, we're going to talk about solving simple equations. In the previous video, we talked about combining like terms, and in the previous video before that, we talked about order of operations. So we want to talk about how we can bring these ideas together to solve simple equations. Now, this first one I have here for you is just 3x equals 6. Put it plain and simple, that would be 3 times an unknown is equal to 6. So we've got to think, what number times 3 equals 6? And that might jump off the page right away. So we think 3 times 2 equals 6. So my answer, x, is equal to 2. Now, this is pretty simple. Doesn't really require much algebraic thinking, just requires more arithmetic thinking, and that's okay. But equations can always get more complicated. So it's always worth thinking through a process and an algorithm, so to speak, that leads us to the answer. So the thing I want to focus on, the two concepts are combining like terms. Make sure that when you're doing these, make sure you're combining like terms, and we are going to use reverse order of operations, okay? So this one is simple enough, I can squeeze it in at the bottom. 3 times a number equals 6. How might I use reverse order of operations to get this answer? Well, I know I'm multiplying 3 and x. And the goal is to simplify so that x is by itself, particularly with a coefficient of 1. So if I'm multiplying 3 and x and I want to get rid of that 3, how I undo that is by dividing. So I will divide this by 3. Now, always remember, an equation is kind of like a fraction. When you simplify a fraction, I always refer to it as a balanced scales. You got to remember to keep it balanced. What you do to the denominator, you must do to the numerator, and vice versa. Same with an equation. What I do to one side, I must do to the other. And so 3 divided by 3 will just simply cancel, and I'm just left with x. This is the goal. I want x by itself on one side of the equation. And again, particularly with its coefficient equal to 1, so you could write 1x, and we still accomplished our goal. You want it to read x or 1x. And then we've got to just do this division on the other side. 6 divided by 3 is 2. So that's the beginning idea of using reverse order of operations. So for the second example, I look at the problem x minus 2 equals 4. And again, we could probably do this in our head. Something minus 2 equals 4. Well, the number that when I subtract 2 gives me 4 is 6. So I know that I'm going to get x equals 6 from this problem. However, let's remember our two rules: combine like terms and reverse order of operations to try and create a mindset for how we can solve these types of problems. The first thing, combining like terms, x and 2 are not like terms. We have an unknown versus 2 units. I can't combine these, okay? So instead, I've got to revert to reverse order of operations. And my operation in particular is the subtraction of 2. And I will undo this by using addition. How do I undo subtraction? I use addition. So I'm going to add 2. And then there's that idea again. What I do to one side of the equation, I must do to the other. So when I follow through with both these additions, I got negative 2 plus 2. Well, that just cancels out to give me 0. That's the goal. I wanted it out of this side of the equation, and I'm just left with x. And this 2 and this x, I also can't combine, because again, it's an unknown and 2. And then here I get 4 plus 2 equals 6. So to reiterate before we move on, combine like terms, reverse order of operations, and remember the goal is to isolate, and it might not even be x. Maybe you'll get problems where it's a or b. The goal is to isolate the variable, okay? All right, so here's a problem, 3x minus 2 equals 4. I'm going to show you in 2 different ways. Remember, I refer to reverse PEMDAS. So that would be addition and subtraction come first, multiplication and division come second, and then exponents we deal with third, and then anything in a parentheses. There is no parentheses or exponents, so we don't need to deal with that. But addition or subtraction, well, I see I've got a subtraction here, so to undo that, I have to add. What I do to one side, I must do to both. So 3x, again, 2 and 3x we can't combine. These just combine with each other and cancel out. 4 plus 2 is 6. And then I use, okay, so I've used my addition subtraction, and now I'm multiplying 3x. How do I undo multiplication? I divide, so I'm going to divide this by 3 and this by 3. That will cancel to 1, and then 6 divided by 3 is 2, and I am done. Now, that's the best way I can recommend to do a problem like this. However, I have this need as a teacher to provide students with options. Everybody's different. Everybody learns different. Sometimes this process won't work for a person. If it works for you, great. You can fast forward past this section of the video. If it doesn't work for you, sometimes what happens is people like to do the division first. That is okay. The only reason why I recommend against that is because you could end up with decimals or fractions, and you have to be ready to deal with that. So if I wanted to, say, use order of operations instead of reverse order of operations on this problem, again, no parentheses, no exponents, so I got to go straight to multiply and divide. Well, I got to look straight to the x for that. I'm multiplying 3 and x. So if you didn't happen to like this previous method, you would start with division on this one. Now, to do to one side, you got to do to the other, but you have to do it to every single term. And this is where the roadblock comes in. 3 and 3 cancel nicely, and I'm left with x. But I'm still left with a minus here, and 2 over 3, that doesn't simplify, so I'm going to leave it as a fraction. Then 4 over 3, that doesn't simplify, so I'm going to leave it as a fraction. So I've dealt with my multiplication division, and now I can add my 2/3 to the other side. And look at what I end up with. This cancels because they're opposites. They should. Addition of fraction, we have the common denominator. That's great. So it'll be out of thirds. And then we add 4 and 2. That's 6. But we end up with the same division that we ended up with anyway. We still got to follow through with 6 divided by 3. And that's 2. Okay? So in a problem like this, there are 2 ways to solve it. The way I'm going to work with moving forward is reverse PEMDAS, okay? And if you prefer this method, then make sure you leave a comment down in the comment section, and I can try to come up with more examples of how to do that. Let's go over another problem. We got 3x minus 2. So again, reverse PEMDAS. Multiplication, division, exponent, and parentheses. So notice now parentheses is at the bottom of the totem pole. And this subtraction that we have here now is within the parentheses. So we don't have any addition subtraction to work with. So we can't do that. So we have to go to multiply, divide. We're multiplying 3 by this entire quantity, x minus 2. So when I divide by 3, I do it to both sides, but this cancels out, leaving me just the x minus 2. And actually, at this point, we can drop the parentheses. We don't need them at this point. The purpose of dividing by 3 was so we could get rid of the parentheses. And 3 divided by 3 is 1. So we multiply and divide. Now we backtrack to our addition and subtraction, and we can add 2 to both sides, and we get x equals 3. Now, if you, really quickly, I'll just throw this out there. If you want to, you may distribute. I'll let you work this one out on your own. But if you can distribute and just drop the parentheses anyway, and then move forward with regular reverse order of operations. All right, one last problem to kind of set the mood on how complicated this can get. And this isn't even the most complicated. It's just the most complicated I'm willing to go for this video. So again, reverse order of operations. All right. I began the last problem, or ended the last problem by saying you could distribute the 3 if you wanted to. You can't do that because this is an exponent of 3. Remember that this means I'm taking this quantity and I'm multiplying it by itself 3 times. Dang it, I don't know why I keep writing 3. So to distribute it would be to distribute it to each and every one of these, which would be inappropriate. So we'll start with the addition and subtraction. We're going to want to subtract 1. So 1 minus 1, that cancels. I'm just left with the quantity of 3 times x minus 2, quantity cubed. 4 minus 1 is 3. Because I can't distribute this, I'm going to go ahead and divide by 3. Okay, that cancels. Divide by 3 here. I get x minus 2 cubed. 3 over 3 is 1. And now the exponent. How do we deal with the exponent? Well, I need the process of undoing a multiplication of something by itself 3 times. That would be the cube root. And I'll cube root both sides. And so what I'm left with is just x minus 2, because this cancels. And cube root of 1, that's simple. That's just 1. Luckily, that came out to be the way it was. Otherwise, I would have had to leave it as a radical. And now we circle back to addition subtraction, but really this is just the parenthesis portion of it. We add 2 to finish off our answer, and we get x equals 3. Go ahead and like and subscribe and leave a comment. If you want to see more videos like this, leave them in the comment section below. Thank you for watching.